There is something rather extraordinary and perhaps deeply troubling that happens when you step outside on a truly dark, clear night. Away from the glare of our cities, away from the blinding, artificial glow of human civilization that masks the reality of our environment, you look up, and you are immediately confronted by the sheer, unadulterated majesty of the Milky Way. It is a river of light, a cold, shimmering tapestry woven from billions of ancient suns, suspended in an abyss of unimaginable depth. For as long as human beings have had the cognitive capacity to wonder, for as long as our distant ancestors sat around primitive campfires on the African savanna, we have looked up at that glittering vault and asked a very natural, deeply human question. We ask, are we alone? We project our own desires for companionship, for meaning, and for context onto the silent stars. But in the modern era, armed with our profound understanding of physics, of astrophysics, and of the evolutionary history of our own planet, that innocent, romantic question has evolved into something sharper. It has become something far more mysterious and, frankly, something rather haunting. It was the brilliant Italian physicist Enrico Fermi who famously encapsulated this creeping sense of cosmic dread over a casual lunch with his colleagues in the summer of 1950. Amidst a light-hearted conversation about flying saucers and interstellar travel, Fermi reportedly fell silent, performed a few rapid mental calculations, and simply asked, "Where is everybody?" To truly grasp the weight of Fermi's question, to understand why it keeps astronomers and philosophers awake at night, we have to first understand the scale of the stage upon which this cosmic drama is playing out. And the scale is, without exaggeration, entirely beyond the capacity of the human mind to easily visualize. We are not wired to comprehend the numbers that dictate the reality of our universe. We live in a cosmos that burst into existence roughly 13.8 billion years ago. That is an expanse of deep time so vast, so deep, that our entire human history, the rise and fall of every empire, the building of the pyramids, the writing of every book, the utterance of every word, is barely a fleeting fraction of a cosmic second. All of human civilization is merely a thin, precarious layer of frost on the very tip of an unimaginably vast iceberg of time. And within this ancient universe, space itself has expanded to encompass a volume that defies our everyday terrestrial comprehension. In our Milky Way galaxy alone, we estimate there are somewhere between 200 billion and 400 billion stars. Hundreds of billions of thermonuclear furnaces burning steadily in the cold vacuum of space, held together by the invisible, relentless grip of gravity. But the Milky Way, as majestic as it appears from our vantage point, is just our local neighborhood. It is merely one isolated island in a staggering cosmic archipelago. When we point our most powerful telescopes, like the Hubble or the James Webb Space Telescope, at tiny, seemingly empty patches of the night sky, patches so small you could cover them with a grain of sand held at arm's length, we do not see emptiness. We see galaxies. Thousands upon thousands of them, stacked upon one another, stretching back to the dawn of time. The observable universe contains perhaps 2 trillion galaxies, each containing hundreds of billions of stars of their own. The mathematics becomes almost paralyzing. We are talking about vastly more stars in the observable universe than there are grains of sand on every beach, on every coastline, across the entire surface of the Earth. Trillions upon trillions of suns. But stars, of course, are just turbulent spheres of fusing plasma. They are not, in themselves, the homes of life. For biology to take root, for complex chemistry to occur, you need a stable platform. You need planets. And for a very long time, throughout the majority of human history, and well into the 20th century, we didn't actually know if our solar system was a cosmic anomaly. We simply didn't know if other stars had planets orbiting them, or if the formation of Earth was a freak occurrence, a unique accident of planetary accretion. Over the last few decades, however, our instruments have grown spectacularly sophisticated. Space telescopes like Kepler were designed with one specific purpose: to stare unblinking at a single patch of sky and watch for the minuscule dimming of starlight that occurs when a planet passes in front of its host star. And what they found has utterly revolutionized our understanding of our place in the cosmos. They delivered a definitive, breathtaking answer. Planets are everywhere. They are the rule, not the exception. We now know that almost every single star you see in the night sky hosts at least one planet. And a staggering percentage of those stars host rocky planets, worlds roughly the size and mass of Earth, orbiting at just the right distance from their host star, the Goldilocks zone. Not too hot for the water to boil away into space, and not too cold for it to freeze solid. Just right for liquid water to pool and flow and sculpt the surfaces of billions of alien worlds. And it is not just the planetary real estate that is plentiful, it is the building blocks of life itself. The chemistry of the cosmos is entirely, demonstrably conducive to biology. The elements that make up your body right now, the carbon in your DNA, the oxygen in your lungs, the iron carrying blood to your brain, the calcium in your bones, they were not created at the dawn of time in the Big Bang. The early universe contained only hydrogen, helium, and a tiny trace of lithium. The heavier elements, the complex atoms required for life, had to be forged. And they were forged in the nuclear fires of dying stars. They were cooked in the crushing pressures of stellar cores over billions of years. And then, when those massive stars reached the end of their lives, they violently detonated in immense supernova explosions, flinging those precious elements across the interstellar void. Every atom in your body was once inside a star that exploded before the Earth was even formed. You are, quite literally, made of stardust. The universe is heavily, inevitably, seeded with the exact ingredients required for life. The building blocks are universal. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. These elements are floating in vast molecular clouds, raining down on young, newly formed worlds across the galaxy. The laws of chemistry are the same everywhere. The way atoms bond, the way molecules fold, the way complex organic compounds form in the presence of energy and liquid water. These are fundamental properties of the universe. So, if you combine the sheer, terrifying age of the universe, the staggering, near-infinite number of habitable worlds, and the ubiquitous, universal nature of the chemical building blocks of life, you are left with an inescapable, probabilistic conclusion. A conclusion that seems so robust, so mathematically sound, that to deny it feels almost foolish. The universe shouldn't just be capable of hosting life. It should be absolutely teeming with it. It should be overflowing with biology. And crucially, given the 13.8 billion years that the universe has existed, it shouldn't just be microbial life. Simple, single-celled organisms might be churning away in the dark oceans of a billion worlds, but there has been more than enough time, vast oceans of time, for life to evolve, to grow complex, to develop nervous systems, to spark intelligence, and to build advanced, star-spanning technological civilizations. Consider the timeline. Our solar system is roughly 4.6 billion years old. Our planet took a long time to cool, a long time for life to emerge from the primordial oceans, and billions of years more for that life to crawl onto land and eventually look up at the stars. But the universe was already 9 billion years old when our sun first ignited from a collapsing cloud of gas and dust. That means there were countless stars and countless Earth-like planets that had a multi-billion-year head start on us. Imagine a civilization that didn't just start the process of the Industrial Revolution a few hundred years ago, like our own, but millions, or perhaps even billions of years ago. The technological capabilities of a civilization that ancient would appear to us as completely indistinguishable from magic. They would have had the time to conquer disease, to master the complete manipulation of matter, to harness the total energy output of their host stars. We theorize about colossal megastructures like Dyson spheres, massive arrays of solar collectors, completely encapsulating a star to harvest every single drop of its radiant energy. A civilization a million years older than ours wouldn't just be theorizing about them, they would be building them. Furthermore, they would have had the time to build spacecraft capable of traversing the vast interstellar distances. Even if we assume that faster-than-light travel is a physical impossibility, forever forbidden by the absolute laws of Einstein's relativity, the galaxy is still entirely conquerable. Even moving at a fraction of the speed of light, using propulsion technologies we can already envision, like nuclear pulse propulsion or vast light sails pushed by high-powered lasers, an expanding, colonizing civilization could spread across the entire Milky Way galaxy in a few million years. They could build self-replicating machines, von Neumann probes, that travel to a nearby star system, mine the asteroids for resources, build 2 copies of themselves, and launch those copies to the next stars. This process of exponential growth means that a single, sufficiently advanced civilization could explore and populate the entire galaxy in an incredibly short amount of cosmic time, a mere blink of an eye compared to the age of the universe. So, logic dictates, mathematics demands, and probability screams that we should see them. We should hear them. The night sky should not be a quiet, pristine wilderness. It should be a vibrant, noisy, bustling metropolis of interstellar commerce, cosmic engineering, and artificial signals. We should detect the intense, unnatural exhaust plumes of massive starships decelerating as they enter new solar systems. We should see the unmistakable artificial thermal signatures of heavily engineered stars, their light dimmed and shifted into the infrared by the massive energy-harvesting structures built around them. Or, at the very, very least, we should detect the chaotic wash of radio transmissions, the electromagnetic chatter of a billion worlds leaking out into the cosmic dark. For decades we have actively looked. We have built monumental instruments, massive radio dishes nestled in valleys and spread across deserts, specifically designed to listen for the faint, artificial whispers of extraterrestrial intelligence. The search for extraterrestrial intelligence, or SETI, has scanned the heavens, tuning into the frequencies we believe a rational civilization would use to communicate. We have pored over the data, hoping to find a pattern, a prime number sequence, a beacon cutting through the natural static of the cosmos. But what do we actually hear? What do we actually see when we listen with our great radio dishes and peer through our most sensitive orbital observatories? Nothing. Complete, absolute, terrifying silence. We listen to the cosmic static, the hiss of the cosmic microwave background, the chaotic radiation of pulsars and quasars, and we hear no voices. We search the spectra of distant stars, analyzing their light for the chemical signatures of industrial pollution or artificial elements, and we find no anomalies. We scan the horizon of our own solar system, looking for the lingering artifacts of ancient visitors or the silent, watching eyes of alien probes, and we find nothing but dead rock and cold ice. There is no grand galactic federation. There is no great cosmic chorus singing across the light years. There is only a profound, deafening emptiness. Not a faint whisper, not a single unambiguously artificial signal, not a single verifiable trace of cosmic engineering. Just an endless, silent, spectacularly beautiful void. And that is the true, chilling essence of the Fermi Paradox. It is not just an intellectual puzzle, it is a jarring, violent contradiction between the overwhelmingly high probability of extraterrestrial life and the absolute, uncompromising zero evidence for its existence. It is the friction between what our mathematics tells us must be true and what our observations tell us is undeniably real. This silence is far more than a scientific curiosity. It is an existential weight that bears down upon anyone who truly comprehends its implications. It forces us to confront our own reflection in the cold, dark glass of the cosmos. When we call out into the dark, projecting our radio waves and our golden records into the void, and we hear only the cold echo of our own voices returning to us, a profound sense of isolation washes over the human spirit. We are forced to consider a deeply uncomfortable possibility. We have to consider that perhaps we have vastly misunderstood the nature of the universe, or, perhaps far more worryingly, that we have vastly misunderstood the nature of life itself. The silence is deeply unsettling precisely because it implies a hidden danger. It implies a mechanism at work in the shadows of the universe that we cannot see, but whose effects are undeniably apparent in the emptiness of the night sky. It suggests that the long, complex journey from a primordial soup of chemicals to a star-faring, technologically advanced civilization is not a gentle, inevitable upward slope. It is not a guaranteed trajectory driven by the simple passage of time. The universe, it seems, is not a fertile, welcoming garden, patiently waiting to be harvested by the seeds of consciousness. It is a harsh, unforgiving, and deeply lethal crucible. If the fundamental ingredients of life are scattered everywhere, if the habitable planets number in the billions, and if the time available for evolution is practically limitless, yet the skies remain empty and the radios remain silent, then something, some immense unseen force or mechanism, must be stopping them. Something must be standing in the path of life's progression. Something must be actively, ruthlessly preventing biology from fulfilling its technological destiny and spreading across the stars. The cosmos is laid out before us, spectacularly vast and seemingly ripe with potential. It harbors a silent reality that relentlessly dictates the rise and fall of everything that dares to organize itself into living matter. This hidden mechanism, this unseen barrier that seems to stand between the emergence of raw biology and the glittering, star-spanning civilizations we imagine, was brilliantly conceptualized by the economist Robin Hanson. He called it the Great Filter. The idea is as elegant as it is terrifying. It suggests that in the long, precarious sequence of evolutionary and technological steps required for a species to arise from simple chemistry and eventually colonize the galaxy, there is at least one step that is incredibly, improbably difficult. A bottleneck so narrow, a wall so high, that almost nothing ever makes it through. When we look out at the silent universe, we are forced to ask ourselves a question that carries the ultimate existential weight. Where exactly does this great filter lie? Is it behind us, buried somewhere in our deep evolutionary past? Or is it ahead of us, lurking in our immediate technological future? If the great filter is behind us, then we are the beneficiaries of a miraculous, statistically absurd sequence of cosmic accidents. And when you trace the history of life on Earth, you begin to see where these monstrous bottlenecks might be. We often fall into the trap of viewing evolution as a ladder, a predetermined march of progress from simple to complex, from mindless matter to conscious astronomers looking through telescopes. But evolution is not a ladder. It is a blind, unthinking, undirected process. It has no goal, no foresight, and absolutely no preference for intelligence. Consider the very dawn of life. The transition from non-living chemistry to self-replicating biology, a process known as abiogenesis, might be the first great filter. Perhaps the universe is filled with warm, wet, rocky planets that remain forever sterile because the initial spark of life is a mathematical near impossibility. Yet, given how quickly life seemed to arise on Earth once the crust cooled, almost the geological blink of an eye, many astrobiologists suspect that simple, single-celled life might actually be quite common. The cosmos might be teeming with microbial slime. But here is where the story of Earth takes a profoundly sobering turn. For roughly 2 billion years, life on this planet did absolutely nothing but exist as simple, single-celled organisms. 2 billion years of bacteria and archaea, blindly dividing in the dark, primordial oceans. They didn't build complex structures, they didn't form tissues, and they certainly didn't evolve nervous systems. They were stuck. It took a freak occurrence, a microscopic accident of breathtaking improbability, to break the deadlock. Sometime around 2 billion years ago, one simple cell swallowed another. But crucially, instead of digesting it, the host cell incorporated it. The swallowed cell became the mitochondria, the power plant of the modern complex cell. This event, known as endosymbiosis, provided the enormous energetic leap required to build complex eukaryotic cells, the building blocks of all fungi, plants, and animals. As far as we can tell from the fossil record, this incredibly precise genetic merger only happened once in the entire 4 billion year history of life on Earth. Once. Every single complex organism alive today, from the towering redwood trees to the blue whales to you and me, is descended from that single, accidental fusion. If that is the great filter, then perhaps the galaxy is full of living worlds, but they are worlds populated entirely by single-celled organisms, forever trapped on the wrong side of a biological energy barrier, completely incapable of evolving into anything that could ever look up and wonder. But let us suppose that complex cells are not the filter. Let us assume that given enough billions of years, multicellularity and complex nervous systems eventually arise. We still must confront the deeply uncomfortable reality of our own intelligence. We suffer from a severe case of anthropic bias. We look at our cities, our poetry, our spacecraft, and we assume that high-level technological intelligence is the ultimate, inevitable pinnacle of evolution. It is not. In fact, if you look closely at the history of our planet, high intelligence appears to be a highly specific, wildly expensive, and largely unnecessary evolutionary strategy. Brains are incredibly metabolically expensive organs. They consume a vast amount of the body's energy. For the vast majority of Earth's history, evolution has favored armor, speed, camouflage, and physical strength over raw intellect. Consider the dinosaurs. They were a spectacularly successful lineage. They dominated the Earth for over 150 million years. They evolved into a dazzling array of forms, occupying every ecological niche. Yet, in all those millions of years, they never invented the wheel, let alone radio astronomy. They didn't need to. They were perfectly adapted to their environment without the need to understand quantum mechanics. Evolution was perfectly content to leave the Earth as a Jurassic paradise forever. We are not the intended outcome of the universe. We are, in a very real biological sense, a cosmic mistake. We are a fluke. We are the descendants of a specific lineage of vulnerable, relatively weak apes who were forced out of the receding forests of the East African Rift Valley by shifting climate patterns. Forced to walk upright across the dangerous, open savanna. We lacked the claws of the lion, the speed of the cheetah, the armor of the rhinoceros. To survive, we were forced to rely on social cooperation, tool use, and a mutant, oversized cerebral cortex that allowed us to model the future and outsmart our predators. Our intelligence was a desperate survival mechanism forged in a very specific, unforgiving crucible. There was absolutely no guarantee that any other species on any other world would face that exact sequence of evolutionary pressures. The universe could be filled with lush, complex biospheres, teeming with millions of species, not one of which has the slightest inclination to build a radio transmitter. They might be perfectly, beautifully adapted to their worlds, living in eternal equilibrium, entirely ignorant of the stars above them. If human-level intelligence is the great filter, then we are an anomaly, a statistical aberration wandering alone in a universe that neither expected us nor needs us. But there is an alternative, and it is a chilling one. What if the genesis of life is common? What if the leap to complex cells is inevitable? What if evolutionary pressures frequently drive species toward high intelligence and tool use? What if, right now, the galaxy is scattered with the ruins of thousands of civilizations that arose, looked up at the stars, and then vanished? If the great filter is not behind us in our evolutionary past, then it must lie ahead of us in our technological future. And when we look at the trajectory of our own civilization over the last century, the nature of this filter becomes terrifyingly obvious. The very traits that drive a species to conquer its homeworld, ambition, tribalism, resource acquisition, aggression, are the exact same traits that threaten its existence once it reaches the technological threshold. We are a species of Paleolithic hunter-gatherers, driven by ancient territorial instincts, who have suddenly been handed the power of gods. We have brains wired for short-term survival on the African savanna, yet we are attempting to manage the long-term stability of a globally interconnected, nuclear-armed civilization. This is a profoundly dangerous mismatch. Any civilization that wishes to cross the interstellar void must first master vast amounts of energy. You cannot build starships with windmills and solar panels alone. You must unlock the profound, fundamental power of the atom. You must learn to manipulate the very forces that hold the nucleus together. But the moment a civilization unlocks the secrets of nuclear physics, they don't just gain the ability to power a starship, they gain the ability to extinguish themselves in an afternoon. We crossed that threshold in 1945 in the desert of New Mexico, and for the last 8 decades, we have lived with a sword of Damocles hanging over our heads. We came perilously close to the brink of complete annihilation during the Cold War. The Cuban Missile Crisis was not resolved by some inherent, elevated wisdom of the human species. It was resolved by sheer, unadulterated luck, by the hesitation of a few individuals under unimaginable pressure. We cannot rely on luck forever. It is a mathematical certainty that if you play a game of nuclear roulette long enough, eventually, the chamber will not be empty. Perhaps this is the fate of all advanced civilizations. They grow, they innovate, they spread across their planet, and eventually, inevitably, they discover the ultimate weapons. And because they are products of Darwinian evolution, driven by competition and fear of the other, they eventually use them. The silence of the universe might be the silence of a radioactive graveyard, a cosmos littered with charred, irradiated husks of worlds where clever, foolish creatures simply failed to survive their own technological adolescence. But even if a civilization somehow navigates the treacherous waters of nuclear proliferation, they immediately face a second, perhaps even more insidious filter ahead of them: the filter of the biosphere. To build a global, high-energy civilization requires the massive extraction and consumption of resources. It requires industry. It requires burning fuel, clearing land, and altering the chemical composition of the atmosphere and the oceans. We are currently witnessing this on Earth. In our relentless pursuit of economic growth, in our desperate scramble to elevate billions out of poverty, we are fundamentally destabilizing the delicate life support system of our own planet. We are altering the climate, acidifying the oceans, and driving the 6th mass extinction event in Earth's history. The laws of thermodynamics are absolute. You cannot have infinite exponential growth on a finite planet. It is a physical impossibility. Yet, our entire global economic system is built upon the illusion that we can. Perhaps every civilization hits this wall. They industrialize. They exploit their planet's resources to reach the stars. But in doing so, they poison the very well from which they drink. Before they can build the grand generation ships, before they can establish self-sustaining colonies on other worlds, their agricultural systems collapse under the weight of a shifting climate. Their societies fracture under the strain of resource depletion. They descend into resource wars, famine, and societal collapse. They don't die in a sudden, spectacular flash of atomic fire, but rather in a slow, agonizing whimper of ecological exhaustion. They become trapped. Their technological infrastructure crumbles, and the survivors are forced back into a pre-industrial existence, living amidst the rusting monuments of their ancestors' hubris, forever chained to a depleted world, looking up at the stars they once dreamed of reaching, knowing they will never leave. This is the great looming shadow of the Fermi Paradox. The silence is not peaceful. It is a deafening warning. It is a stark physical demonstration that survival is not guaranteed. The universe does not care about our ambitions. It does not care about our art, our science, or our beautiful dreams of a galactic future. The cosmos is a brutal, uncompromising arena governed by indifferent laws of physics and biology. If a species cannot learn to master its own base instincts, if it cannot learn to live in sustainable equilibrium with its biosphere, the universe will simply erase it. It will snuff it out without a moment's hesitation and continue its silent, eternal expansion. When we point our telescopes into the dark, we are not just looking for neighbors. We are looking for reassurance. We are desperately searching for proof that it is possible to survive the transition we are currently undergoing. We want to see a civilization that has made it through the Great Filter, a civilization that has successfully navigated the perilous gap between the discovery of nuclear power and the attainment of a stable, sustainable, multiplanetary existence. But we see nothing. And the longer we look, the longer the silence stretches on, the more the grim reality begins to settle in. It suggests a deeply uncomfortable truth about the nature of intelligent life. It suggests that intelligence, rather than being the universe's ultimate survival tool, might actually be a lethal mutation. It might be a brilliant, beautiful spark that burns incredibly brightly for a microscopic fraction of cosmic time, only to inevitably consume the very fuel that sustains it. The Great Filter stands before us, a monolithic judge of our worthiness to exist in the broader cosmos. We are currently standing exactly on the threshold. We possess the power to destroy ourselves, and we possess the power to irrevocably degrade our only home. The question is not whether the Great Filter exists. The silence of the sky proves that it does. The only question that matters, the only question that will determine whether humanity is a permanent feature of the universe or a brief, forgotten anomaly, is whether we have the wisdom, the restraint, and the profound foresight to pass through it. And yet, even if we were to somehow perform this miracle, even if we were to unite as a species, stabilize our biosphere, and survive our technological adolescence, we must then confront the physical reality of the universe itself. We must face the fact that surviving is not the same as escaping, because surviving, as monumental an achievement as that would be, is fundamentally not the same thing as escaping. We have been conditioned by decades of brilliant, captivating science fiction to view the stars as our inevitable destination. We watch films and read novels where humanity effortlessly glides across the galactic spiral arm, zipping from one star system to another, engaging in grand interstellar commerce and diplomacy. We have internalized this narrative so deeply that we treat it as a prophecy rather than a fantasy. We assume that because we went from the first powered flight at Kitty Hawk to landing on the moon in a mere 66 years, the leap to the next star is simply a matter of time, a matter of waiting for the engineers to catch up with our imaginations. But the universe does not care about our imaginations. The universe is governed by laws, absolute and unbreakable, and those laws have essentially quarantined us. When we ask, "Where is everybody?" we must confront the staggering, paralyzing reality of physical distance and the ultimate speed limit of the cosmos. In 1905, Albert Einstein published his theory of special relativity, and in doing so, he laid down the fundamental geometry of the universe. He revealed that space and time are not separate entities, but an interwoven fabric, and that within this fabric there is a cosmic speed limit, the speed of light in a vacuum. Roughly 300,000 kilometers per second. It is a speed so fast that a beam of light can circle the Earth's equator 7.5 times in a single second. Yet, when you place that speed against the backdrop of the Milky Way galaxy, it slows to an agonizing, frustrating crawl. Our nearest stellar neighbor, the Proxima Centauri system, is roughly 4.2 light-years away. That means that if we could somehow build a ship that travels at the absolute maximum speed the universe allows, which, for a physical object with mass, is utterly impossible, it would still take more than 4 years to get there. But we cannot travel at the speed of light. The equations of relativity are merciless. As an object with mass accelerates, the energy required to continue accelerating it increases exponentially. To push a single, solitary electron to the speed of light would require an infinite amount of energy. To push a massive generation ship, constructed of heavy metals, filled with water, atmosphere, and human beings, to even a fraction of the speed of light, would require more energy than our entire civilization has generated in its history. It is not an engineering problem to be solved by clever propulsion systems or novel reactor designs. It is a fundamental wall built into the architecture of reality. Let us look at our actual, practical achievements. The fastest object ever launched by human beings that is leaving our solar system is the Voyager 1 spacecraft. It has been flying through the dark since 1977, accelerated by the gravitational slingshots of the gas giants, and it is currently traveling at a mind-bending 17 kilometers per second. That is incredibly fast by terrestrial standards, but at that speed, if Voyager 1 were aimed directly at Proxima Centauri, which it is not, it would take something like 73,000 years to arrive. 73,000 years. To put that into perspective, human recorded history, the entirety of our written records, stretches back barely 5,000 years. 73,000 years ago, Our ancestors were barely clinging to survival in small, isolated hunter-gatherer bands during the last ice age. We are talking about timescales that completely obliterate the biological and sociological continuity of the human species. And so, we invent the concept of the generation ship. We imagine building colossal, self-contained habitats, spinning in the void to simulate gravity, carrying a founding population of thousands on a journey lasting millennia. Generations would be born, live their entire lives, and die within the confines of a metal tube, surrounded by the absolute zero of deep space, knowing nothing of the Earth but what they see in ancient video archives, and knowing they will never see the destination. But when you truly examine this idea through the lens of biology and ecology, it crumbles into dust. We are not ethereal minds that can be neatly packed into a hard drive and shipped across the galaxy. We are biological organisms, deeply, inextricably embedded in the immense complexity of Earth's biosphere. We rely on millions of other species, from the bacteria in our gut to the fungi in the soil, to the photosynthesizing plankton in the oceans, to keep us alive. We have evolved over 4 billion years to exist precisely here, at one standard atmosphere of pressure, protected by a specific magnetic field, under the light of a specific yellow dwarf star. We cannot simply pack a few tomato seeds, some water recyclers, and a flock of chickens into a spaceship and expect a balanced, self-sustaining ecosystem to survive for 10,000 years. The sheer chaos of biological systems, the inevitable genetic bottlenecks, the radiation environment of deep space, and the profound psychological devastation of permanent, inescapable confinement make the generation ship a beautifully tragic impossibility. We are Earthlings. We are bound to this rock not merely by gravity, but by the very chemical makeup of our blood and bones. So, if we are trapped, then surely any other civilization that arises in the galaxy is equally trapped. The immense gulfs of space act as an impenetrable quarantine, separating the islands of life from one another. Even if a civilization survives its technological adolescence, even if they stabilize their planet and live in harmony with their biosphere for millions of years, they are still physically isolated. They cannot build vast galactic empires. They cannot dispatch armadas of starships to conquer their neighbors. They are confined to their home systems, listening to the static of the cosmos, staring out across distances that can never be crossed. But the physical vastness of space is only half of the barrier. It is only one half of the illusion of the reachable stars. The other half, perhaps the more profound and melancholy half, is the abyss of time. When we look up at the night sky and wonder where everyone is, we implicitly imagine the universe as a synchronized stage. We imagine that the cosmic play is happening right now, with all the actors present, saying their lines at the exact same moment. But the universe is not synchronized. The universe is a staggeringly deep ocean of time. 13.8 billion years. It is a number so large it loses all emotional resonance. So let us attempt to scale it down. Imagine the entire history of the universe compressed into a single calendar year, beginning with the Big Bang at the very first stroke of midnight on January 1st. In this cosmic calendar, every month represents a little over 1 billion years. The Milky Way galaxy forms around middle of March. Our Sun and the Earth do not even form until late August. Life on Earth, the first simple, single-celled organisms, appear around late September. For all of October, November, and most of December, life remains microscopic and simple. It is not until roughly December 15th that the Cambrian explosion occurs, and complex animal life fills the oceans. The dinosaurs appear around Christmas Day, and they are wiped out by the asteroid impact on December 30th. And humanity? The entire story of the human species, our evolution from apes, our migration out of Africa, the discovery of fire, the invention of agriculture, the building of cities, the writing of Shakespeare, the splitting of the atom, and the launching of the Apollo missions, all of it occurs in the very last few minutes of the very last day of the year. Our technological, radio-transmitting civilization has existed for a fraction of a cosmic second. Now, Apply this temporal scale to the search for extraterrestrial intelligence. For us to communicate with another civilization, or even just detect their signals, two things must align perfectly: space and time. They must be close enough that their signals can reach us before dissipating into the background noise of the cosmos. And crucially, they must be transmitting at the exact right moment in cosmic history for those signals to wash over the Earth exactly when we have the radio dishes turned on and pointed in their direction. Imagine the galaxy as a vast, dark, silent forest. Occasionally, very rarely, a firefly blinks into existence. It flashes its light, a technological civilization reaching the stage where it can manipulate radio waves or build lasers. But a technological civilization might not last very long. As we discussed earlier, the Great Filter, the threats of nuclear annihilation or ecological collapse, might limit the lifespan of a star-faring species to a few thousand years, perhaps even just a few centuries. So the firefly blinks on, burns brightly for a fraction of a second, and then is extinguished. A million years later, on the other side of the dark forest, another firefly blinks on, flashes for a brief moment, and dies out. And then another, 10 million years after that. The galaxy might have hosted millions of magnificent, intelligent civilizations over the past 10 billion years. There might have been empires of the mind, poetry written in 1,000 different alien languages, great scientific discoveries made on worlds lit by binary suns. But if their civilizations only lasted for 10,000 years, they represent a microscopic sliver of time. They rise, they look up at the empty sky, they ask, "Where is everybody?" And then they fade into the dust. They never overlap. They never see each other. They are separated not just by billions of kilometers of empty space, but by billions of years of silent, indifferent time. When we point our radio telescopes at the stars, we are scanning the heavens for a very specific, very rare occurrence. We are hoping to catch the flash of a firefly that just happens to be shining at the exact moment we are looking. But the signal from a civilization 10,000 light-years away takes 10,000 years to reach us. If we detect a signal tonight, it was sent by a species that was alive when human beings were still painting hunting scenes on the walls of caves. By the time we receive the message, send a reply, and wait another 10,000 years for it to reach them, that civilization might have been dead and gone for 20 millennia. Interstellar communication is not a conversation. It is an exercise in cosmic archaeology. It is sifting through the electromagnetic ruins of a galaxy that is vast, old, and fundamentally disconnected. This temporal isolation explains the Fermi Paradox just as forcefully as the physical isolation. Why is the sky silent? Because we are late to the party, or perhaps we are incredibly early. Because the window of time in which a civilization is capable of transmitting across the stars is brutally short compared to the lifespan of a galaxy. Perhaps, a billion years ago, when the Earth was nothing but a ball of rock covered in an ocean of slime and primitive bacteria, a glorious, galaxy-spanning radio broadcast washed over our solar system. The universe was briefly loud, filled with the chatter of 1,000 worlds. But there was no one here to listen. There were no radio dishes, no SETI scientists, only the slow, blind march of single-celled biology, completely oblivious to the grand cosmic symphony passing right through it. The signal continued on out into the deep void, never to return. And perhaps, a billion years from now, long after the sun has begun to expand, long after the Earth's oceans have boiled away, and the last traces of human history have been scorched from the surface of our planet, another species will arise on a distant world. They will build their own telescopes, they will look out into the silent dark, and they will feel the same profound loneliness that we feel today. They will have missed us, completely and entirely, just as we have missed whoever came before us. We are, in all likelihood, trapped in our own tiny bubble of space and time. We are marooned on a magnificent, fragile island, surrounded by an ocean that is too vast to sail, and separated from any potential neighbors by gulfs of time so deep they defy comprehension. The universe is not a bustling community waiting for us to join it. It is a scattered archipelago of fleeting, isolated moments of consciousness, rising and falling in the dark, forever out of reach of one another. When we finally accept this, when we truly internalize the sheer, uncompromising scale of our physical and temporal isolation. A profound psychological shift is required. For generations, the idea of a populated universe has served as a kind of cosmic safety net for the human psyche. We have comforted ourselves with the thought that we are part of a grander interstellar community, even if we haven't formally been introduced yet. We have projected our hopes onto the stars, imagining that older, wiser civilizations are out there, perhaps watching over us, perhaps waiting for us to reach a certain level of technological maturity before welcoming us into a galactic federation. We dream that if we ever truly stumble, if we ever push our planet to the absolute brink of ruin, there might be some external salvation, or at the very least, somewhere else for us to go. But the deafening silence of the Fermi Paradox, coupled with the unbreakable laws of physics, systematically dismantles these comforting illusions. There is no one watching over us. There is no benevolent fleet of starships waiting in the wings to intervene if we trigger a nuclear holocaust or tip our climate into an irreversible hothouse state. No one is coming to save us from ourselves, and equally, there is no escape hatch. We hear the constant, seductive drumbeat from Silicon Valley billionaires and space enthusiasts that we must become a multiplanetary species to ensure our survival. They point to Mars, a freezing, irradiated, atmospherically dead desert, and call it our backup planet. They sell us the fantasy that if we ruin the Earth, the brightest and wealthiest among us can simply pack up and start again in a glass dome on another world. It is a deeply dangerous, fundamentally arrogant delusion. To build a self-sustaining, independent biosphere on Mars, a planet with no magnetosphere to deflect lethal solar radiation, with toxic soil, and with an average temperature of minus 60 degrees Celsius, is not merely an engineering challenge. It is an act of biological hubris that completely ignores our absolute dependence on the intricately balanced 4-billion-year-old life support system of Earth. You cannot easily sever a species from the evolutionary cradle that forged every single cell in its body. If we cannot manage to stabilize the climate of Earth, a planet perfectly tailored for our survival, a planet where the air is breathable, the water is liquid, and the soil is fertile, the idea that we could somehow engineer a dead rock millions of miles away into a thriving sanctuary is utterly absurd. We are not going to colonize the Milky Way. We are not going to relocate our civilization to the stars. We are born of the Earth. We are perfectly adapted to the Earth, and we are, for all practical purposes, permanently marooned on the Earth. And I realize that to say this out loud, to categorically close the door on the great science fiction dream of galactic empire, sounds to many like a deeply pessimistic, even depressing conclusion. It sounds like a surrender. But I believe it is the exact opposite. I believe that accepting our absolute isolation is the most vital, the most empowering, and the most fiercely urgent awakening we can possibly experience. Because when you strip away the fantasy of a populated cosmos, when you accept that the night sky is silent and empty of peers, you are forced to look at our own world with entirely new eyes. You are forced to recognize the sheer, staggering improbability of our existence. Look around you. Look at a simple forest, or a coral reef, or even just a handful of damp soil. What you are seeing is not normal. It is not the standard state of the universe. The standard state of the universe is freezing vacuum, deadly radiation, and lifeless rock. The universe is a staggeringly vast, unimaginably hostile machine. But here, on this one microscopic grain of silica, orbiting a wonderfully ordinary yellow star, the universe has done something magnificent. Through billions of years of blind, relentless, unthinking evolution, the atoms forged in the hearts of dying stars have assembled themselves into complex molecules. Those molecules have built cells. Those cells have built organisms. And those organisms have eventually evolved nervous systems, brains, and consciousness. We are not just things in the universe. We are what happens when the universe takes 4 billion years to wake up. We are the cosmos made conscious. We are the very mechanism by which the universe is able to observe its own majesty, to comprehend its own vastness, and to wonder about its own origins. Without consciousness, without the spark of a mind to perceive it, what is the universe? It is just a play of blind forces, a silent, meaningless dance of gravity and electromagnetism, of stars detonating in the dark and black holes tearing apart empty space. Without a mind to witness it, there is no beauty, there is no tragedy, there is no awe, and there is no meaning. Meaning is not a fundamental property of physics. Meaning does not exist in the cosmic microwave background radiation. Meaning is something that we bring to the cosmos. When you look at it from this perspective, our isolation is not a punishment. It is an extraordinary, almost sacred privilege. If the galaxy is indeed dead, if the great filter has scoured the stars of life, or if the sheer vastness of time and space has permanently separated the flickering candles of intelligence from one another, then the responsibility that falls upon our shoulders is absolute. We are the sole custodians of meaning in our corner of the universe. If we were to wipe ourselves out, if we succumb to the ancient tribal instincts that arm our nuclear silos, or if we blindly consume our biosphere until it collapses, we would not just be ending the human story. We would be extinguishing the only known light of consciousness in a radius of perhaps millions of light years. We would be plunging this magnificent, beautiful region of the cosmos back into the eternal, unthinking dark. The silence of the universe would return, permanent and unbroken. That is the true weight of the Fermi Paradox. It is a mirror held up to our species, reflecting not a crowded, bustling galaxy, but our own precarious, infinitely precious existence. It tells us that we are the lucky ones. We are the survivors of the brutal lottery of cosmic evolution. We have successfully navigated the microscopic odds of abiogenesis, the bottleneck of complex cells, and the harsh realities of the African savanna. We have reached the threshold of technological power. Now, we face the final, ultimate test. We have to grow up. We have to transcend the aggressive, short-term thinking that brought us to the top of the food chain, but which now threatens to drag us into oblivion. We must stop looking outward for salvation and start looking inward, at our own societies, our own economies, and our own relationship with the living world that sustains us. The tremendous intellectual energy and vast financial resources we currently pour into dreams of escaping Earth, into designing Mars rockets and hypothetical generation ships, must be entirely refocused. The ingenuity that splits the atom and sequences the human genome must be directed toward the singular, defining challenge of our time: building a sustainable, equitable, and stable civilization right here. We need to learn how to generate power without poisoning our atmosphere. We need to learn how to feed billions of people without destroying the ecological foundations of agriculture. We need to learn how to manage our profound technological power without constantly threatening to annihilate ourselves in a geopolitical tantrum. This is not a retreat from greatness. This is the definition of greatness. The true measure of an advanced civilization is not how many planets it has planted its flag upon, or how many stars it has enclosed in energy-harvesting spheres. The true measure of a civilization is its longevity. It is its wisdom. It is its ability to recognize the constraints of reality and build a flourishing existence within them. Imagine a future, 10,000 years from now, where humanity is still here. We haven't conquered the galaxy, but we have mastered ourselves. We have stabilized the climate. We have preserved the spectacular biodiversity of this planet, allowing the great whales to still swim in the oceans and the forests to still breathe. We have built societies that value knowledge, compassion, and art over endless destructive extraction. We still look up at the stars. We still study them with colossal telescopes. We still marvel at the silent, majestic machinery of the cosmos. But we do so not with a desperate yearning to escape, but with a profound, quiet gratitude for the sanctuary we occupy. That is a future worth fighting for. That is a future that respects the astronomical improbability of our existence. So, when you step outside tonight and look up at the glittering river of the Milky Way, I want you to feel the silence. Don't let it frighten you. Let it focus you. Let it remind you of the staggering physical reality of our situation. Where is everybody? They are not there. The stars are beautiful, but they are cold, and they are unimaginably distant, and they are dead. The universe will not provide for us. The universe will not rescue us. It has given us exactly one chance, one perfectly positioned rock, one incredibly resilient but finite biosphere. We are alone. We have always been alone. We will always be alone. But look around you. Look at the people you love. Look at the towering achievements of human art and science. Look at the breathtaking beauty of the natural world, from the microscopic intricacies of a leaf to the terrifying majesty of a thunderstorm. We have each other, and we have Earth. And if we are wise enough to appreciate it, if we are courageous enough to protect it, and if we are mature enough to finally accept our role as the permanent, responsible stewards of this tiny, fragile oasis, then Earth is enough. It is more than enough. It is everything.